the talk about it. My name is Eran Toch. I'm a faculty member at Tel Aviv University. And I'm happy to introduce our first speaker who will present it physically, and then we have 3 more talks that will be online. Please, you're welcome for the Q&A. If you're online, please write your questions on the Hub app, on the Hub technology. Of course, if you're here, you're welcome to ask questions face-to-face. So our first speaker is Tianshi Li from Carnegie Mellon University, and she'll present the first talk, Understanding Challenges for Developers to Create Accurate Privacy Nutrition Labels. This talk had received an honorable mention, so thank you. That's great. And somebody told me that Tianshi Li is now on the job market, so if you're in the next cycle, next year. So if you're excited about it and you're looking for a new tenure track faculty, she's your candidate.
Thank you. Yeah, thanks, Eran, for the introduction. Hi, everyone. Good morning. I'm Tianshi Li from Carnegie Mellon University, and today I'm happy to present our work, Understanding Challenges for Developers to Create Accurate Privacy Nutrition Labels, on behalf of my co-authors, Kayla, Yuvraj, Lorrie, and Jason. Researchers proposed privacy nutrition labels, which are standardized privacy notices that are similar to food nutrition labels, but they can offer users a clear, uniform, and brief summary of how your data is collected, used, and shared. So this concept has now made its way from the research labs into the 2 major mobile app stores. Apple was the first to require all of their apps on the App Store to provide a privacy nutrition label since December 2020. And then Google announced a similar requirement coming in early 2022. So developers play a crucial role in creating the privacy nutrition labels. Prior research has studied the usability of privacy nutrition labels from the user's perspective, but we have very limited understanding about developers' ability to create accurate privacy nutrition labels. So in this work, we wanted to bridge this gap by conducting the research from the developer's perspective. So our study is focused on Apple's privacy nutrition label. From a user's perspective, Apple's privacy label allows you to see not only what data types are collected by an app, but also how the data is collected, including what data is used to track you, and also what data is linked to you. Currently, the process of creating privacy label, Apple privacy label, is like filling out a questionnaire. So the developer first need to answer one question. Did you or your third-party partners collect any data from this app? And only if their answer is yes to the first question will they be taken to the second step, and they will select all the data types that are collected by the app from a list of predefined options. And finally, they need to provide further details for each data type that they selected, including the data collection purposes, whether the data is linked to the user, and whether the data is used to track users. In July and August 2021, we conducted studies with 12 iOS developers remotely to understand developers' experiences and perceptions about this process. Our sample features a diverse set of developers, including developers from different countries, develop apps of different sizes, for different purposes, and also served different roles. I'll briefly summarize our study method, and you can see more details in the paper. Our study consists of 2 parts. The first part, we asked the developer to create a privacy label of their own apps, of one of their own apps, using the replica of Apple's tool. And the second part of the study was a semi-structured interview in which we collectively identified the errors and misunderstandings in the privacy label with the developer and then probed into what caused these errors. So our first finding was that the general reaction of developers to the requirement of creating the privacy label was positive. And some developers even found that the requirement of the side effect of the requirement to force them to think more about privacy as a positive thing. However, we also identified a lot of errors and misunderstandings in their answers. Specifically, 9 out of these 12 developers made errors, and they were not able to correct them before they were prompted by the interviewer. And among the 8 apps that already had a privacy label before the study, 6 of them were recreated inconsistently. As we expected, underreporting was a common error. One example is that many developers mistakenly think data linked to user only refers to data that is identifiable on its own, while according to the official definition, it also refers to data that is not identifiable on its own, but is stored with other identifiable data. Like in this chart, the data of last login record is stored with the user ID, but developers only consider that the user ID data type is data linked to the user. In fact, they should also report product interaction data type as data linked to users because it represents the user login time record. Surprisingly, over-reporting was also a common error. For example, some developers think location tracking is definitely something that needs to be considered as data used to track users, but in Apple's definition, the term track only means tracking for advertising purposes. And in several cases, developers reported continuously collecting location in the background as data used to track users, although they're not using them for advertising purposes. We have talked about 2 types of errors, underreporting and overreporting, and then we identified 3 types of challenges that can provide us with some insights into what caused these errors. I'll talk a little bit about the unknown unknowns challenges and the task complexity challenges, and you can find more information about the 3 challenges in the paper. Unknown unknown refers to situations that when developers don't realize that they don't know something. And one main example is that developer relied on their preconceptions of concepts a lot, but these preconceptions usually differ from Apple's definition. For example, as we have just seen before, when developers saw the word tracking, they immediately think about concepts like location tracking, user behavior tracking, or bug tracking, while none of them was covered by Apple's definition, which is linking data with third-party data for advertising purposes. And we found sometimes these misunderstandings even persisted after we prompting the developer to recheck the definitions. We also found that sometimes wrong answers regarding third-party libraries' data practices were not because these libraries did not disclose what data they collected, but because the developers had no idea that these resources were available. So one important lesson we can learn here is only providing this documentation is not sufficient. We need to make sure that developers can easily find them and use them. And next, I want to talk about the implications of the task complexity. Developers complained that they needed to read a lot of text, and we also observed that developers often forgot the concepts they just read about during the study. This means if developers want to get all the answers correct, they have to read and reread the definitions all the time. And consequently, developers may get lazy and don't update their privacy labels on time. As P1 mentioned in our interview, he would likely review the privacy label twice a year, and that means in the 6-month gap, the app could collect data without telling users. Another issue is that although Google and Apple used similar concepts and even the same term in their definition, in their privacy label, their definitions differ substantially from each other. And the inconsistent design of these different platforms could cause for additional pain for future cross-platform app developers. So our work demonstrated a dilemma. we want to leverage developers' knowledge to provide users with a thorough disclosure of how their data is collected, but developers are not privacy experts and they receive little support for privacy, which has led to inaccurate privacy nutrition labels. So next, I'll propose some ideas to address these issues. For platforms like Apple and Google, there are actually some small changes that can easily adopt to mitigate some issues. So for example, they can improve the clarity of their definitions by removing some ambiguous wording, clarify common misconceptions, and also check the internal validity and consistency of the labels. But to fundamentally solve the problem, we argue that usable privacy research needs to pay more attention to developers. And a promising direction is to leverage program analysis techniques to provide developers with timely feedback on potential errors on their labels, and also to support automated or semi-automated generation of privacy labels. So in some of my prior work, I have looked at how to use annotations embedded in code to help developers with privacy. In Coconut, which is an IDE plugin I built for Android development, developers can annotate their data practices directly at the place where the data is collected and can get privacy suggestions as they're coding. And then in Honeysuckle, which is another IDE plugin I built, it can translate the same privacy annotations into the implementation of in-app privacy notices. And I think future research can explore using a similar idea to generate privacy nutrition labels that conform to a standardized framework. To sum up, we present the first study examining the privacy nutrition label creation process from the developer's perspective. We found that developers' misunderstandings and the complexity of the task can make it very difficult for developers to create accurate privacy nutrition labels, and we want to call for more future research to provide better developer support for this task. And that's the end of my talk. I'm happy to take any question and chat more after the talk. And by the way, I have 2 other papers at this CHI, and I hope to also see you there. Thank you so much.
The talk. This is Nate. So you looked at the alignment between actual app practices, content of the app, and the sort of legal text that defines the policies. But I wonder about the alignment between practices and what users expect, right? So, for example, I think users would find it surprising that the definition of collect is inconsistent across Android and Apple.
Yes.
And so they might get upset. Why is this app across the 2 different things behaving in a different way? And the answer is it's not behaving in a different way. The definitions are different. Have you looked at that other half?
Yeah, I think that's a good question. And I think, first of all, there has been a very large body of work that's trying to improve the transparency and to make all of these disclosure of data practices usable to end users. And I think it's definitely important to investigate whether these terms are intuitive to end users and what they mean actually matches the user's understanding. And I think this work is kind of probing a similar issue, but more from a developer's perspective. I think for 2 reasons. The first reason is if developers don't provide the accurate information, then it has there will be no benefit to end users. So we want to make sure the first step is done correctly. And also, I think so usually we think developers have more knowledge about these technical concepts than end users. And if there are already a lot of misunderstandings to developers, then I can imagine there will also be a lot of confusion to end users. So I think a meaningful next step will definitely be we also investigate how end users perceive these concepts. But I think we can maybe even think further because we don't want to only solve only this problem at this time. So if we only make sure Apple's definitions is correct, then maybe next time Google propose something and then it's not correct, and then we need to redo it all over again. So I think some better solution will be something that integrate more programming analysis, and then integrate more developer support, like the idea of generate the privacy nutrition label. So then the developer will provide more like annotations or just some results from the code analysis that are less ambiguous, and then we just translate these concepts into whatever formats that is meaningful to developers and users, and maybe they're in different languages. So I think in that way we can bridge the gap between developers, and it will be more generalizable than we investigate like one thing at a time. Yeah, that's my understanding.
Thanks. Has there been any thought put into generating these privacy notices automatically from the APIs the developers use?
Oh, so you mean generating from APIs? Yeah, so actually that's something I'm currently investigating. As I have shown in my slides, I have built some IDE plugin like Coconut and Honeysuckle. Those IDE plugins are actually analyzing the APIs used in the app, like sensitive source APIs that accesses sensitive resources, or sync APIs that send the data to the network. And then we want to detect these. So that's definitely just only one possible solution, but we think we can maybe track these APIs and then generate some templates or annotations for developers to fill out. I think this is something that we cannot completely automate because there are a lot of information that we cannot easily analyze, like what are the purposes for using the data and what are the accurate data flows. But we can do like part of them automatically, and then we can bring this information to developers to fill out the rest of the information. So developers will do less work, and we will, in the end, get a more accurate privacy label for everyone. Yeah. Thank you.